My name is Sebastian, and in this video I want to show you how to use searches with Neo4j. That means if we have a Neo4j graph database, how to do searching in that database and show and use the results in our application. At first I will show you how full-text indexes work and then other mechanisms such as regex searches. So if we look into this full-text search index that Neo4j offers, it works as follows: that at first we have to define an index and then we can use and query that index. I want to do that using my coffee example that I showed earlier, in which I have a list of many coffee beans that have certain attributes, but now I'm interested mainly in the name that I would like to search for. So assuming I know the name of a particular bean out of that list that I just want to search. So how to do this? There are multiple ways, and at first I would like to show you full-text indexes. You can have a look at the documentation, how they actually work, and you will see that they are powered by some searching engine, which is quite interesting, and that will actually have an impact on our search results or how we would need to use them. And by doing so, or if I want to use them, I have to define an index first. So there's something, I will show you just a scratch pad here. How to do this: I can call a procedure here, db-index full-text create node index, in which I create an index like the name suggests. I give it a name, I index specific labels, in my case that label is coffee bean, and specific properties. I could of course index multiple things. I could also query them across multiple types, across multiple labels. By the way, I can also query relationships, but now I want to focus on nodes. And I basically execute that on my database. So I go, in my case, on the database browser, or you would usually include it in your script for setting that up. And then I would like to just execute and have my node index being created. Okay, by the way, I can also list these indexes and have a look that this is now created. I have some other constraints for my other type of beans as well, but here I see the full text index here on my coffee bean. All right, then how I use this index is as follows: that I can query another query. So I call here another procedure, query nodes. That's what I would like to have. I want to query my nodes by using this full text index, and then a specific query that I'm about to define. What that gives you, it yields a node, basically a collection of nodes, and a score for each node, so that tuple. And with that score, it has a somewhat certainty, or how much actually this matches the search that you would like to have. So it has some scoring included, by which you can, for example, sort then, which is what we are going to do. So what we have to do is we have to define a query here. Like this, for example, we would like to search for la, which is included in a lot of beans, and then return this with just a particular node, or maybe the node name for that matter, and then sort it by the score that we have. So if we execute that, then we get a lot of bean names in which it says, well, la something, or in the middle, La Paz here, and all of these are included there. So that's quite interesting to begin with. But then it depends actually what the full text engine is, or what the analyzer mode is, that we actually can switch in a second as well, or also how I conduct the search. So if I just fire it up as such, then I can include this, and I can, for example, say, well, search for a second word, for example, La Paz here. And what you will see, that it does not only include La Paz here, it includes it at the first term. Why? Because of the score. We can actually show the score as well. But also it includes all of the other ones that don't match it exactly, but for example, only include La. But it's quite interesting to see that we also have to match the whole word. This is how this works. It basically takes my full text, or all of the properties that I have and tokenizes them depending on a specific strategy. And for that, then I have these searches that go on each tokenized word basically. So then I have la, which needs to match, and pas as well. So if I had another part of it, so for example, if I would like to search for AMI here, then it would not work in the same way, that it actually would not include that particular result. Why? Because the whole word doesn't match here. And for that reason, I would need to find a different way of searching. But first of all, for that, it does a tokenized search, what that is called. And if I now want to search just for that particular one and for other ones, I can include it as such. If you have a look at the documentation and how this engine works, you will also see that you can actually combine some things with some additional operators. For example, I can say la and pas, which then interestingly gives me only that result, because that is then an AND search and both tokens need to match. So this is how that works. What's also quite interesting, I can actually include this in quotes, which would look something as follows, that I can have that as well, which now also has to match this one. So then this does a literal search on that particular part. Let's put that here for that word as well. Let's find a different one. Let's say LA and then an M. This also doesn't work. Why? Because it doesn't match the whole word then on the second word. But if I say la pas, it matches this particular example again. So this just shows you that you have to be a little bit careful what you model here, and specifically which sort of mode of that search engine you use. So there's that you can do a literal search, that you can use operators. You can have a look at the documentation how that works exactly, and you can construct your searches by doing so. And now that interesting part is also how these sort of tokenized mechanisms work. And for that, we can have a look at if we can conduct the query, the index in a different way. So what is available if I call for some DB index list available analyzers? If I find this out, then you will see that the default actually works with so-called stop words, with English stop words, that we see, well, the words, you can read it for yourself, like but, and, or, and so on and so forth. They are then actually not being taken into account in that particular search. In other words, if your query or if your nodes contain that, it will just be basically ignored. So you will see that this works for actually all kinds of languages. So for many languages here are supported out of the box. So just, typical words and that you would, if you conduct a broader search, not like to include. But again, this really depends on what you would like to do. If you have a longer text or this typical full text analysis, then it certainly makes sense to ignore them. Other than that, you might want to just not include them as such. How this works then is that you can choose a different analyzer. For example, you can say analyzer simple, that you can just pass it as an argument if you construct this here. And then you will see the simple analyzer, for example, has no such stop words. It would just use the spaces as such to separate it. It's also possible to not use any tokenization, not any spaces at all. Then you have to match to the whole text. But then this also, that's a question whether it defies the purpose of a search, because then you also pretty much have to know the whole text, and you're not particularly conducting that search if you only know some part of the word or some variation. So these are some of the most interesting mechanisms how to use such an index. But now let's include this in our application, shall we? So we can use that particular example in our coffee shop. And how this works is that I already have some mechanisms to query the beans via HTTP, for example. And what I would like to include as well is some searching mechanism. So for that particular JAX REST controller, which then gives me that possibility via HTTP, I would, for example, like to say, well, use some searches. So post a new search with some method here. Say that should give me a list of coffee beans, list because it might be sorted. I say search and then search for the query param. Let's call this query, string query, and then, well, pass it on to this bean what we already created in the previous video for these coffee beans. So this basically has the possibility to use my Neo4j OGM session factory to just, well, provide something like this. How this works is that I would like to include another method somewhere here. Let's say that should be the search method. So I have coffee bean and then search for that particular query. Like that will be invoked here, coffee beans search for that query. And then in this case, what I would like to do, well, I would basically like to call that query, so call that index, and then go over the results. Please sort them by what you likely would like to have, and then return them as coffee beans. So basically populate all of these fields. Now, what we can do here is similar to what we had in the past if we would like to use this OGM capabilities, that we say we have a session, a factory, please open a session, and use that session to query all this coffee bean class for a particular query. I will use these multi-line strings again, include the parameter of a query, and then basically what we had in our scratchpad here, it should be similar to this. So I can say I would like to include that. Please query that particular index, yield the node score, return just a node here, and order them as such. And then please take this. That will just give me this iterable. And I have this method here that just will produce that list based on what was the result here. Okay, that's basically how we could use them. That's one example how to use them in our Java application. And now I would like to actually use that. I already have that application running. And now let's say I would like to query that. So this is basically localhost 8080 beans and then searches, plural. I would like to post a new search, and I do so with these query parameter, query, search query. And now I would like to search for this LA at first. So let's see. This worked. So it gives us basically a big JSON of these beans. You will notice, and this is again what I was explaining in the previous video, that these flavor profiles are not populated unless we also return this information. So what you would like to have in this case, if that were interesting for you, if it's not only the names but the whole information of that particular mapped OGM class, then what you would need to do is, instead of returning that immediately, you also have to match then the other properties and relations what you would like to include. That is a little bit similar to what we have with the other queries. For example, if I say I would need to have these optional matches just to make sure that all of the other information is included, if that were interesting. Now, what we are interested in actually is just the names. So I will return this differently, that it gives me just the JSON and say something like overall just take the name, which gives us the name here. And now we see that this is pretty much now similar what we have in what we had in our graph browser. And I can, for example, now include a second word here as well. Now I need to pay attention how I actually encode this. So typically this is now URL encoding because I use this as a parameter. So %20 is a space. If I include pass here as well, then you will see that this is now being returned as the first one. Now again, what we just saw in the query browser, that's now similar. If I would like to include this in my application, I need to make sure how the quotes or the extra operators work here. So for instance, if I would like to say and, Now this looks a little bit weird. Then it would give me that same result. So this is now something I could provide. So as another example, what I could do, I could go and then include some quotes as well. How this works in URL encoding is a little bit weird. So now some more weird characters. Percentage 22 is a double quote. And if I include that as such, it will then, well, first of all, not return a result anymore because the and doesn't match here. So I say only La Paz and then in quote. And then this matches this particular part again. So that is similar to what we saw in the query browser. And again, if you would like to have that or just pay attention about how this works, you have to have a look at what you actually perform in your application. So whether you include quotes or you want to add them, depending on how you want your user to conduct the search. So this is basically how that works for querying and using full text indexes. And now what I would like to show you also is a regex example or some other types of searching. For example, if you would like to say, I would like to search a particular bean and I know it was la and then some m or something with m. So this, as you saw already, this would not work with that particular way. Why? Because it conducts the search on these tokenized results. So I would need to know basically the whole word. And what I can do instead is to do regexes. So I would like to have something like, please search for that and then m and then, wildcard, something similar to that. And this does work. There is a possibility to search for regexes as well, like in just a regular match query with where. That works as well. How this is done, that's a little bit simpler even. So we don't even need full text indexes for that. It's just a question what you would like to implement there. But basically, to give you an example, I do this as follows, that I write a similar method here now with just some search for some regex. And basically what I would like to have, I would like to provide a regex and then provide the result here. Okay, so let's include that here. What I would like to write then is as follows, that I need to match something. So I need to match, for example, my coffee bean. And then it's quite straightforward that I say, okay, where the bean name, and that is the operator for a regex search here. So something that is then searched by a regex. So I could also say, well, equals, but that's just, then the whole name has to match. And then I would include my regex here. And then, of course, well, depends what you like to do. So then you can go further and have anything else that you would like to do with your node. So that's basically a normal match where you just add this where. But in my case, I just want to return the bean here. You can, for example, order it by the name, doesn't really matter, bean.name, and you can return it as such. Okay. In order to include that, here I would now, just for testing purposes, like to include another query. I call this query param, so basically a boolean, whether that's a regex. Let's say regex here, for default that's no. So I include, so that you can see it, a false here, and that should just be a simple switch. So if it's a regex, please then use this coffee beans, search for regex, and that's it. And then it will use it as such. Okay, let's see if that works. What I would like to include now here is that regex search. So I would like to have, let's start with something simple again, LA, and then basically regex is true. And what I would like to do, I include this now into quotes, otherwise my shell will complain and trying to make some sense out of the wildcards. So now here you say that this is empty. Why? Because this doesn't match anymore. So I can include this dot star, and by the way, I have to match now again the case. So I could include something more there that I say, well, please make everything lowercase and then match it for that as well. So this depends what you would like to do. But basically now it searches for everything, this LA dot and then something. Well, basically that's a wildcard match, the dot star. Or I say, well, everything before there as well, that it includes some more. Okay, now what is not available quite straightforwardly is that score. So now we would need to make more sense of what is actually available here. And then also, well, what I would like to search, let's say in my previous example, if I would like to have la and then something, m, so that would be also that space again, and then an M, and then something else. So that's basically the search I wanted to conduct. If I know, well, it started with la and then some M and some word, then I can solve this by using some regex search. So I suggest that. So that's a thing that you have to keep in mind. So the scoring is a little bit different, or it's not available out of the box. And also a few other things, like if this is user provided, you definitely need to do proper testing, whether this regex and the search being provided with quotes or without quotes and so on and so forth does work actually. You also would like to sanitize the user input that is being provided, because also there are some things such as regex bombs. You can search for explosive quantifier trap. So this is something where then a regex can get out of hand if it's especially user provided. So you definitely need to take a little bit more care of that than just this. But that's basically some of the easy options that you have in order to do some searches with Neo4j by either using these full text indexes or by using where predicates in which you search for something specific. So I hope that was interesting. As always, you can get the code on GitHub, link down below. If it was helpful to you, I would really appreciate a like, and thank you very much for watching.